In this section, we are going to explain the other transport layer protocol, Transmission Control Protocol, TCP. We first want to have an overview of TCP protocol. TCP, Transmission Control Protocol, was specially designed to provide a reliable end-to-end byte stream over an unreliable internetwork. TCP must dynamically adapt to different topologies, bandwidths, delays, packet sizes, and so on, and must be robust to failures. Therefore, for TCP, it is a quite challenging task to achieve reliability. It involves complex control scheme compared with UDP. Each machine supporting TCP has a TCP entity, either a user process or part of the operating system kernel that manages TCP streams and interfaces to the IP layer. TCP handles the encapsulation and the de-encapsulation of TCP segments and converts it between data stream and pieces. A TCP entity accepts user data streams from local processes, breaks them up into pieces not exceeding 64 kilobytes. In practice, usually about 1,460 bytes in order to fit in a single Ethernet frame with the IP and TCP headers, and then sends each piece as a separate IP datagram. When the IP datagram containing TCP data arrives at a machine, they are given to the TCP entity, which reconstructs the original data stream. TCP service model. TCP service is obtained by having both the sender and the receiver create endpoints called socket. Each socket has a number address consisting of the IP address of the host and a 16-bit number local to that host called port. Port number below 124 are called well-known ports and are reserved for standard services. For TCP service, 3 features should be emphasized. All TCP connections are full duplex and point-to-point. TCP does not support multicasting or broadcasting. A TCP connection is a byte stream, not a message stream. We now take a close look on TCP protocol. The sending and receiving TCP entities exchange data in the form of segment. A segment consists of a fixed 20 bytes header plus an optional part, followed by 0 or more data bytes. The TCP software decides how big segments should be. 2 limits restrict the segment size. Each TCP segment must fit in the 65,535 bytes IP payload, and each TCP segment must fit in the maximum transfer unit of the underlying network, that is 1,500 bytes for the Ethernet payload field. The basic protocol used by TCP entities is the sliding window protocol. The TCP segment format is shown in this diagram. Besides the fields such like port number, checksum, we can find it is much more complex than UDP. We can find sequence number and acknowledge number, which are used for reliable communication. We can also say window size, which is for flow control. Other fields, such like ECK, SYN, FIN, and so on, they are mostly for the synchronization and management of the connections between two ends. Now, we want to find out how TCP connection is established. TCP uses an approach which is called a three-way handshake to establish connections. It works in 3 steps. Step 1. One side, the server, passively listens for incoming connection. Step 2. The other side, the client, connects to the server with a connection request and sets out the parameters. Step 3. The server replies with an acknowledgement and the connection is set. TCP connection should be released when the connection is over. To release a connection, either party can send a TCP segment with the same bit set, which means that it has no more data to transmit. When the FIN is acknowledged, that direction is shut down. When both directions have been shut down, the connection is released. To avoid two-army problem, timers are used. If a response to a FIN is not forthcoming within 2 maximum packet lifetime, the sender of the FIN releases the connection. The other side will eventually notice that nobody seems to be listening to it anymore, and time out as well. In theory, this protocol can fail if the initial disconnect request, DR, and the retransmissions are all lost. The sender will give up and delete the connection, while the other side knows nothing at all about the attempts to disconnect, and it is still fully active. This situation results in half-open connection. There is one way to kill off half-open connection. If no TBDUs have arrived for a certain number of seconds, the connection is automatically disconnected. It is necessary for each transport entity to have a timer that is stopped and then restart when a TBDU is sent. If this timer expires, a dummy TBDU is transmitted. The quiz of this section is to require you to compare 2 transport layer protocols we have learned, the comparison between UDP and TCP. That's it for this section. Thank you.